In the last video, I covered how DC generators work. Even though a DC generator is one of the most efficient ways to generate electricity, it does require an external power source like coal to work. This is why in this video, I will be talking about the solar panel, a renewable and long-term way to generate electricity. This is a part 2 of a 2-video series where I talk about 2 major different ways to generate electricity. Welcome to... Though I will be talking about solar energy in this video, I am only going to be talking about solar cells, not other forms of generating energy by taking advantage of solar, a solar water heater for example. However, applications of solar energy and the pros and cons will be talked about further down the video. Before I move on, I will be covering the history of the solar cell and the solar panel first. The first solar cell was invented in 1839 by a French physicist named Edmond Becquerel. The cell was made with metal electrodes submerged in a conductive solution. Edmond noted that the cell produced more current when it was exposed to light. The biggest leap in solar technology happened when the silicon solar cell was created by 3 scientists, Darrell Chapin, Calvin Fuller, and Gerald Pearson, working at Bell Labs. Silicon is widely abundant, and its better efficiency makes it the most widely used type of solar cell. Solar panels are made up of many smaller units called solar cells. A silicon solar cell is made up of a piece of silicon that is sandwiched between 2 conductive layers. The silicon atoms are bonded to each other through 4 bonds. This prevents the electrons from moving around freely. A silicon solar cell actually uses 2 different layers of silicon. A N-type silicon, which contains more electrons, and a P-type silicon, which has a lot of spaces where the electrons can be in, called holes. The place where these 2 types of silicon meet is called the p-n junction. Electrons can move freely through the p-n junction. This creates a positive charge on one side and a negative charge on the other. Light from the sun can be thought of as many tiny particles traveling at great speeds. These particles are called photons, and they are very important for solar energy. When a photon hits the silicon cell hard enough, it dislodges one of the electrons. This leaves a negatively charged electron and a positively charged hole. As a result of the electric field at the p-n junction, the electron will be drawn to the n side, and the position of the hole will go to the p side. These electrons are collected by the conductive layers and are integrated into an external circuit powering the load. The electrons return back to the solar cell and go to their respective holes again. This cycle repeats as long as there is a continuous supply of photons striking the solar cell. One photovoltaic cell puts out around half to 1 volt, but you can wire multiple cells together to power more energy-demanding loads, such as a light bulb, phone, or even an entire house. It all depends on how efficient the solar cells are, how many are joined together, and how much light the solar cell is exposed to. The solar technology we have today is totally adequate to power large machines, such as satellites and off-the-grid housing options. Creating a solar panel setup that is reliable and efficient is pretty difficult to say the least. For efficient power generation, the solar panels need to be placed somewhere sunlight can reach them most of the time. The panels themselves need a sprinkler system, especially in dusty areas, to prevent excessive dust blockage, hampering energy generation. For reliability, a battery reservoir should be installed as insurance for nighttime use or any technical failures. Solar panels have various benefits when it comes to reliability and cost. First, it is a renewable way to generate electricity. The sun is a virtually limitless source of energy. Solar is almost emissions-free. The only emissions that come from solar panels is during production. After that, it is a great way to generate electricity with no emissions. Second, the money you'll need to spend on maintenance for a solar panel far underweighs the cost of normal electricity bills. Solar panels are also more reliable, as batteries can last you through times of outages. Solar panels also do have their flaws when it comes to upfront cost and condition requirements. First, solar panels need a lot of area to generate enough electricity to be a considerable way to generate electricity. People with less land would have to resort to other options. Second, even though long-term capital is less with solar panels, purchasing enough solar panels to suit your power needs will get pretty pricey. Solar panels also cannot work in places where there is frequent cloud coverage or places where there are frequent dust storms.